Hi, I'm Savannah Franco.
And I'm Taylor Geyer.
And we're here to tell you about solutions.
What is a solution? Well, a solution is a homogeneous mixture.
A homogeneous mixture is a mixture which has uniform properties throughout, meaning it looks completely clear of pieces, for example, milk, blood, or water.
In a solution, the solvent is a substance in the largest amount, what you put in the solute, and the solute is what you put in the solvent.
For example, when pouring sugar in water, sugar would be the solute and water would be the solvent, because the sugar, the solute, is dissolving in the water, the solvent, therefore making a solution.
When something is soluble, it is capable of being dissolved. Here's a list to help you determine whether or not an element is soluble.
Nitrates, acetates, and chlorates are soluble.
Alkali metals and ammonium are soluble.
Halides are soluble except for when bonded with silver, mercury, or lead.
Sulfates are soluble except when bonded with barium, strontium, calcium, lead, and mercury.
Carbonates, phosphates, and sulfides are insoluble.
Hydroxides are insoluble except when bonded with calcium, barium, or strontium.
Let's take lithium fluoride. Lithium fluoride is soluble because lithium is an alkali metal, and as said before, alkali metals are soluble, as well as ammonium. In ammonium chloride, ammonium is soluble, therefore ammonium chloride is soluble as well.
Here are some factors that may affect a substance dissolving. Surface area may block the solute from dissolving.
Stirring can affect the role of dissolution, and temperature can change, speed, or slow down the process, depending on how hot or cold the solvent is.
Concentration is how strong a solution is. The more solute there is, the more concentrated it will be. The less solute, the more diluted it will be.
Molarity is the amount of solute per liter of solution. So when trying to calculate molarity, you would use the formula M, standing for molarity, equals moles over liters. In the example below, what is the molarity of 0.30 liters solution containing 0.50 moles of NaCl? The equation would look like M equals 0.50 moles over 0.30 liters. Plug that into your calculator and you would get 1.7 M.
Colligative properties are properties that depend on the concentration of the solute, the dissolved in the solvent, and that will change the normal properties of the solvent.
The formula for boiling point elevation is delta T equals molality times number of ions times boiling point constant. The formula for freezing point depression is delta T equals molality times number of ions times the freezing point constant. In this example, calculate the freezing point when 34.5 grams AlCl3 is added to 300 milliliters of water. Assume that the freezing point constant of water is negative 1.86 degrees. So our molality is 2,588 moles over 300, the number of ions is 4, and the freezing point constant is negative 1.86. Multiply those together and you get your delta T is 1,930. If you use 5.76 moles of sodium fluoride and dissolve this into 3.62 kg of water, what will be the change in the boiling point of your sodium? Assume that the boiling point constant of water is 0.512 degrees. Our molality is 5.76 moles. The delta T is 19.7. The number of ions is 3.62, and the boiling point constant is 0.512. Multiply these together, and you get your delta T. Thank you for watching.
Thanks.